As a continuation of the history of the atom, um, I I just talked about Dalton's atomic theory. So you should have already looked at Dalton's atomic theory for this. And as Dalton said before, from his theory, the big thing is that atoms are king. In essence, if you want to know about mass and matter, you're talking about atoms. And as a function of his atomic theory with his four principles, what and the fact that during his time, he basically looked at a lot of other people's work also, besides his own, to come up with his atomic theory, and from that theory and things that were happening at that time, um, three laws were kind of developed. As I said before, the law of conservation of mass, where even though it's the definition is mass is conserved, um, but with Dalton, if everything about mass is about atoms and mass is conserved, then atoms are conserved. And not only is it atoms are conserved, but it's each individual type of atom is also conserved. Also, there are two other laws which you see in front of you. You should have already printed off um, these two handouts that I'm going to be using right now, so you can write on them, or you can just write your notes in some other digital format. Remember, these are not your notes, these are my notes. And if my notes don't make sense or the words aren't right for you, then you need to change them into your notes to make them yours. So, this handout here explains two different laws besides the law of conservation of mass, and one's the law of definite or constant proportion, and you can read. That's about that's with a guy named Proust. Um, you can read what the definition is. Again, it comes from Dalton's atomic theory that says that atoms, since they're indivisible, when they come together to form these things we call compounds, they must come together in a fixed whole number ratio. But since uh, every atom has the same mass, then if it's a fixed whole number ratio, it's also a fixed mass ratio. Remembering that when people say law of definite or law of multiple proportion, they are talking about massing things. So you can do calculations on these, which I'll show you now. On the other handout that you were supposed to done. So here's an example of a law of definite proportion calculation. It says we have a substance that has 75 grams of carbon will combine with 12 grams of hydrogen to form this new substance. So that's that fixed mass ratio. So now what this particular question is asking is, if I have a container of this compound, and I know I have 35.2 grams of carbon, well then how many grams of hydrogen do I need? Okay, well, using your way of doing all math in chemistry, you write down either what you know or what you then what you are looking for, or the other way around. And it looks like this time I did the first thing I did is what I'm looking for, which is grams of hydrogen. What do I know? Well, I know two things. I know that in my new compound I have 35.2 grams of carbon, and that there's a ratio of grams of carbon to grams of hydrogen, which I show. So therefore, this can only be done by dimensional analysis, and of course, since you're looking for 1 unit, you write down 1 unit, which is grams of carbon, and and then your bracket and the line, which is how you do dimensional analysis. And since you want the grams of carbon to go away, the grams of carbon in the parentheses goes on the bottom, and you're looking for grams of hydrogen, that's on the top there. And you have that relationship, and then you realize that you need 5.63 grams of hydrogen, or that there is 5.63 grams of hydrogen in your container, since you have 35.2 grams of carbon. Okay, so that's an example. That's basically the type of question you're going to get. The only other type of question that you'll have is that they give you in either the ratio or the question information about the whole, and they only give you parts. And in that case, you're going to have to do an addition or subtraction. And you know how to show work and how to do significant figures for addition or subtraction besides multiplication division. The one thing I would like you to do is always separate out the addition or subtraction from the multiplication division. So making it two different steps. Okay, and that way it will be easier to know, since you need to apply the correct significant figure rules. So as long as you keep them separate, you'll be fine. Okay, so that's a law of definite proportion example. Now, going back to here, which is the law of multiple proportion. The law of multiple proportion, that is the definition. And it's a long definition. And basically what it means is, for example, if two elements come together to find a compound, like it's called carbon monoxide, C1O1, and this the carbon and the oxygen can come together differently to form a different compound, C1O2. If you have, in that case, you have C1O1 and C1O2, and since there's one C for both of them, if you look at the oxygens, they always must come in the numbers, the little numbers in the subscript must always come in a simple whole number ratio, in this case 1 to 2. Which makes sense, because all law of multiple proportion is talking about, the theory behind it is that you can't break up atoms. In essence, atoms are the smallest thing, so therefore they have to come in whole number ratios. Okay, again, this law of multiple proportion, like definite proportion, is all about massing things. And it's not complicated, but it's just more mathematical manipulations to do these problems. I am not going to require you to do mathematical manipulations on the law of multiple proportion. All I need you to know is you have to understand what it is. Okay, and you don't have to do the math. The only math that you will have to be responsible for in this section is this, which I'm showing you now, the law of definite proportion. And this handout shows you the exact work I'm looking for. Okay, so that's about it. Again, these are the 3 laws that come from Dalton's atomic theory, or the material that is going on around the time of Dalton's atomic theory. Thank you.